We're going to take a look at methods of counting and generating sample spaces. When we talk about counting, what we really mean is determining the number of ways we can choose something. In this example, we wish to order a pizza, and we're going to choose 2 toppings, 1 meat and 1 vegetable. We have 3 meat toppings to choose from: pepperoni, sausage, hamburger, and 3 vegetable toppings to choose from: green peppers, onions, and mushrooms. And there's several different ways you could go about doing this. I'll show you some of those methods here. The first one is very systematic. We could make a list of the possible combinations we could make. So let's say, for example, we want to start with pepperoni. All right, and we'll just say PEP for pepperoni. We could have pepperoni and green peppers, a meat and a vegetable. We could have pepperoni and onions. Again, we have a meat and a vegetable. Or we could choose pepperoni and mushrooms. And so we see there we have 3 different pizzas we could make: pepperoni green pepper, pepperoni onion, pepperoni mushroom. But perhaps we don't want pepperoni. Maybe we decide to go to sausage. Well, let's see the possible pizzas we could make there with sausage and 1 vegetable. We'll say S for sausage. We could have sausage and green peppers. We could have sausage and onion. We could have sausage and mushroom. So we have 3 more pizzas that we could make. If we went with sausage, we could have green pepper or onion or mushroom. But perhaps we don't want sausage. We still have another choice. We could still go with hamburger on our pizza. And so let's suppose we have hamburger. We'll say HB for hamburger. We could have that with green peppers. We could have hamburger with onions, or we could have hamburger with mushrooms. And so there's another 3 possible pizzas that we could make. In total, we see there's 1, 2, 3, 4, 5, 6, 7, 8, 9 different pizzas that we could create out of these 6 toppings. Now, that's one way we can go about this. There are other ways. Let's take a look at another method. We could use what we call a tree diagram. We call it a tree diagram because it looks like a tree. It's going to have branches. And so here's how we'll begin that. We'll begin with our meat. It doesn't matter if you pick the meat or the vegetable first. You can go either way. We could have pepperoni. We could have sausage, or we could have the hamburger. And so we put that on the left-hand side here. Those are the beginning of our branches, the base of our tree. And then we're just going to go through and list the possible vegetables. If we got pepperoni, we could have still had green peppers. We could have had onions, or we could have had mushrooms. And so there's our 3 pizzas with the pepperoni. In fact, we had those back here when we looked at our list. We had pepperoni, onion, mushroom. Here we have pepperoni, green peppers, onion, mushroom. Sausage, again, I could get my sausage with green peppers, with onions, or with mushrooms. And there are my 3 pizzas that we had earlier with green peppers, onions, and mushrooms. Or I could get the hamburger, and again, I could get that with green peppers, onions, or mushrooms. And here are the different pizzas that I could come up with. I don't have a list that's any different. I still have 1, 2, 3, 4, 5, 6, 7, 8, 9 different pizzas that I can make out of these toppings. Now, some people like making the tree. It's a little more organized, and it helps you keep things a little more straightforward. But the tree, or just generating the sample space using the list, either of those methods certainly works fine. Now, if you're not concerned with what the different combinations are, what the different groups are, and you just want to know how many, we can use what we call the counting principle. The counting principle simply says that if you have 2 or more lists and you're going to choose an item from each list, all you've got to do is this. So here's our 2 lists. We had our meat and we had our vegetable. And we say, how many different meats were there to choose from? Well, there were 3 different meats. How many different vegetables were there to choose from? There were 3, green peppers, onions, and mushrooms. We simply take those numbers, 3 times 3, there's 9 different pizzas. And so without listing anything out, I use the counting principle to go ahead and figure out how many different pizzas I could make. Example 2 asks you to go ahead and you have an ice cream shop and they have 5 flavors of ice cream: vanilla, chocolate, strawberry, peach, raspberry. And then you get to choose a topping, hot fudge or marshmallow. I'd go with hot fudge. And they say you choose one of each. How many different sundaes are possible? Please pause here and create a list of ordered pairs. And let's see how you do. So let's take a look. We have here our ordered pairs: vanilla fudge, vanilla marshmallow, chocolate fudge, chocolate marshmallow, strawberry fudge, strawberry marshmallow, peach fudge, peach marshmallow, and raspberry fudge, raspberry marshmallow. It looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different sundaes. 10 different sundaes to choose from. Now, doing our tree diagram, it looks like this. Here we go. We have vanilla, chocolate, peach, raspberry, and strawberry. And we have 2 branches on each one, again giving us 10 combinations. By the way, it doesn't matter if you put the ice cream first or the topping first. Just take a look here. If I went with the topping first, fudge and marshmallow, and then made the branches for the ice cream, vanilla, chocolate, strawberry, raspberry, and peach, vanilla, chocolate, strawberry, raspberry, and peach. Notice here I have 5 of them. Here I have 5 of them. Still gives me 10 total. So it doesn't matter if you pick the flavor of the ice cream first or the topping first. And now, of course, we know we can verify this by using the counting principle. The 2 things we're going to select from is the flavor and then the topping. And the counting principle says, well, we had 5 flavors, 2 toppings. 5 times 2 is 10 different sundaes. So there we go, 3 different ways that we can go ahead and work with this idea of counting how many different ways something can happen. On the next page, we're just going to simply go through and use the counting principle. And let's just take a look at the first one. We have Yang, 4 suits, 10 ties, 8 dress shirts. How many different outfits can be chosen? Well, Yang is going to wear a suit, a tie, and a dress shirt. And so here are our things. Here we have the suit. Here we have the tie. And here we have the shirt. And we fill in the number of things that we have for each choice. We have 4 suits, 10 ties, 8 dress shirts, and now we multiply 4 times 10 times 8. That's 320 different outfits. So our friend Yang can almost go for a year, not exactly a year, a little bit less, and never wear the same combination. All right, please try example 4 and example 5. let's see how you did. Please pause here. So how'd you do? We had the sandwiches with 18 different flavors of filling and 6 different kinds of bread. 18 times 6 is 108 different sandwiches. So you can go to Donna's Deli, and I cannot talk and write at the same time. You can get 108 different sandwiches. Now, number 5, how many outcomes are possible if you roll a die 3 times? Well, you pick it up, you roll it. How many different things can happen the first time? It looks to me like there's 6. You could get a 1, 2, 3, 4, 5, or 6. Second time, you could get a 1, 2, 3, 4, 5, or 6. And the third time, 1, 2, 3, 4, 5, or 6. Multiply them together, you could get 216 different outcomes. So you can see why it would be desirable to use something like this. Imagine making a tree that had, the numbers 1 through 6, and then each of those had 6 branches coming off it for the second roll. And then each of those branches had 6 more coming off of it for the next roll. You'd have 216 branches. It gets pretty busy pretty fast. But when you're working with this, nice and easy, it all comes together very, very beautifully. Let's take a look at the last couple of examples on this page. We have a 4-question true-false quiz. How many ways can that quiz be answered? Number 7, Virginia's tossing a coin 6 times. We want to know how many possible outcomes there are. And number 8, we have 6 roads from Pittsford to Syracuse and 3 from Syracuse to Albany. We want to know how many different routes there are from Pittsford to Albany. Please pause here. Try examples 6, 7, and 8. Let's see how you did. In the first example, we have 4 questions on a true-false quiz. We want to know how many different ways you could fill out that quiz. So you have a Scantron sheet, and you got to put true-false. How many different ways could we put it together? Well, let's see. First question could be true or false. 2 different ways. Second question, true or false. Third, true or false. Fourth, true or false. And the counting principle says we simply multiply those numbers together. 2 times 2 times 2 times 2 is 16. So there's 16 different ways. Next up, we have Virginia. Virginia's tossing a coin. Virginia's my grandmother. And she's tossing a coin 6 times. Now, she flips it. She's going to get either a heads or a tails. Does it again. Going to get a heads or a tails. Does it again. Going to get a heads or a tails. And I think you see what's going on here. 2 possibilities for each time through. Every time she flips it, she could get a heads or a tails. And we have 2 times 2 times 2 times 2 times 2 times 2. There are 64 different outcomes or possible outcomes. So if she's recording her results down, it could happen 64 different ways. Maybe she got all heads the first 5 times and a tails the last time, or maybe she got the first 4 heads and the last 2 tails. Who knows? Finally, we're looking at 6 different roads from Pittsford to Syracuse, 3 from Syracuse to Albany. How many different routes altogether? Once again, counting principle to the rescue. 6 from Pittsford to Syracuse, 3 from Syracuse to Albany. Counting principle says 6 times 3. There are 18 different routes. And so that is how you can use the counting principle to determine how many different ways things can happen. Not only can you use the counting principle, but you could also list ordered pairs, as we did with our pizza, or make a tree diagram. That concludes our lesson on counting methods.